there he ends. It's comfortable there. And then this was our test just to give us glimpse of it. And now I will request Petros to go into the results.
Okay, we performed some statistics to measure some differences. We did have a normal distribution. I can explain afterwards if it's required about normal distribution. So we used non-parametric tests throughout. Here you can see a correlation between, this is in the vertical axis, this is performance in seconds, and horizontal axis, this is age. You can see a positive correlation between age and performance in simulated blue lighting conditions. This is a positive correlation, means that as the age is increased, our performance in such condition is increased as well. R value represents how strong is this correlation. In our case, it's a moderate correlation. And p-value represents our confidence. This is predetermined value. In our case, it's 0.05. It means that we have 95% chance to be accurate. That is the way that we determine if we have a significant correlation or not. This is for our overall sample. Also, for the strobe light, we had the same correlation, a moderate correlation, as you can see. And we tested the mean values of each task to see if there is some differences. And as you can see, the first bar shows the continuous light. This is performance, again, in seconds, in vertical axis. The second bar shows the strobe light performance, and the third bar shows the earth light performance. That symbol here represents the significant differences between the continuous light performance and strobe light performance. The second symbol represents the significant differences between the continuous light performance and earth performance. And the third symbol represents the significant differences between strobe light performance and earth light performance. We also split our sample in men and women, and we wanted to see if the correlation was the same. Actually, we found the same in men in terms of age, the same correlation, and moderate correlation between continuous light performance and age, as you can see. And we found actually a strong correlation in strobe light in men. And here we did not find a significant difference between the continuous light performance and strobe light performance. Instead, we found actually the same results as our overall sample. As you can see, significant differences between continuous light and earth, and significant differences between strobe light and earth. With women, we have again the same correlation between continuous light and age, but we did not have a correlation in terms of strobe light. The results in terms of mean values are exactly the same as the overall sample. We also examined the effects of gender on performance, and we did not find any effect. We intended to examine the BMI effect on performance. We intended to categorize BMI, body mass index, which is something that affects the human performance in there. But because we had only one BMI category, everybody was in normal category. We were not able to do it. Those are our results, and now Rika can explain our limitation.
So you have seen the experiment and the results. Now, as you know, we have done the lunar conditions in the solid hall basement, so we do have limitations. And we had the darkness there, but still our literature survey shows that the luminance varies from 10 to 800 under Earth-shine conditions in the moon. But our illumination was limited to 400 luminance. And we did not try to simulate a combined sun and Earth-shine illumination. Then we have used a depth perception device, a glass, and as as we have seen in the introduction slide, there is the size and shape of the obstacles and the distance of the obstacles may not be the same as we see in the moon because of the lack of atmosphere and also because the sky is dark. So the device used for depth perception may not be the exact judgment of the size and distance of the object as in the moon. And the brain responds to, the brain gives messages differently at a different G. So the visual cues which are essential for working under conditions of 1/6 G was not addressed in the experiment. The gravity we could not create. The moon has different conditions like the earth shine, sunshine, and the combined earth and sunshine conditions. And the obstacles, of course, have shadows behind. And because of the lack of atmosphere, the shadowed part of the moon will be very black. And this aspect was not addressed. And the experiment was limited to, of course, the earthlit conditions only. And we could not get the normal distributions in the statistical analysis, so this shows that our sample size is limited. And of course, the homogeneity of the sample also. We had confined our experiments in the SSP participants, and our body mass index was in the normal range, so we couldn't do in all the 4 categories. So, and the literature survey shows that there is a positive correlation between BMI and visual reaction time. So the conclusions. So the conclusions were separated for men and women. The performance of men with impeded depth perception varies significantly between continuous lunar simulated light and earth light, and the performance of men also varies significantly between strobe lunar simulated light and earth light. And for women, the performance of women varies significantly between continuous lunar simulated light and strobe lunar simulated light, and of course between the continuous lunar simulated light and earth light, between strobe lunar simulated light and earth light, with of course with the glasses. You can see the difference between men and women. And with respect to the age and performance, the performance of men is found to be slower when age increases in continuous simulated lunar light, and it is slower when age increases in strobe simulated lighting conditions. And in the case of women, the performance is slower when age increases in continuous lunar simulated light, but no significant correlation between age of women and strobe light simulated lighting conditions was found. Alan?
Okay. From these results, it really made us scratch our head, and we came up with all sorts of interesting ideas for future research. Basically, some things that we would want to look at is lunar light conditions on a wider age group. We only had a couple of participants in their 70s, but you know, if we're really going to colonize the moon, there's going to be space tourism. You're going to have probably a lot of older people because they're the ones that have the money and can go there. Okay? So it's really important that we get a better understanding of how that age group would react under these different conditions. Also, we need a better method to complement or to define the depth perception between what happens on the moon versus how we're doing in Earth conditions. We're using glasses that basically, for somebody who's nearsighted, and it changes depth perception, and we couldn't really measure it. So this is an area, if we could really figure out a way to define that, I think that would be good research. Lunar lighting effects under sun, Earth, and moon, we didn't change phase angle at all, and that'll be a huge effect when we're working on the moon. Terrain slope, people are going to be going up and down hills. Again, we get a chance to try it under different slant hill conditions. And then what is the minimum safe surface illumination that an astronaut can be working under without using any auxiliary lighting to support that? What is that level? Also, if when the astronauts are working under a condition where you have Earth shine as well as sun, and you have equipment out there, you're going to get some huge glare either off your equipment or off of rocks, and we've got to figure out how to deal with those high glare conditions. So along with that, material surface finishes. How do you figure out what are the right finishes to put on all your equipment to try to